Good morning, everyone, and thank you for attending this course. Today, I'll be discussing a topic called elevator. Elevators, also known as lifts, are essential vertical transportation systems that allow people and goods to move between different floors in buildings. They have evolved from simple, manually operated platforms in ancient times to highly advanced automated systems that are integral to modern high-rise structures. Today, elevators are equipped with cutting-edge technology to ensure safety, speed, and efficiency, making them a crucial component in the design and functionality of residential, commercial, and industrial buildings. Elevator topics: traffic analysis, installation of the guest lift in hotels, construction of elevators, tools required for elevator, testing and commissioning of elevators, elevator emergency rescue operation procedures, operation and maintenance of elevators, elevator troubleshooting, elevator spare parts list, elevator preventive maintenance, elevator control programming, energy saving measures in elevators. First, we are going to learn in detail about traffic analysis. Traffic analysis for selecting number of elevators. As buildings grow taller and more complex, ensuring efficient vertical transportation is key to the overall functionality and user experience. Let's dive into how traffic analysis plays a vital role in this decision-making process. Understanding the importance of traffic analysis in elevator selection. Elevators or lifts are integral to modern architecture. In this slide, we'll cover the history and evolution of elevators and explain why understanding traffic patterns is crucial for selecting the right number of elevators. Elevators as vertical transport. As vertical transportation devices, elevators enable efficient movement between floors, carrying people and goods alike. Historical background. The concept of elevators dates back to ancient times, where primitive versions were powered by human or animal labor. Technological advancements. The 19th century introduced innovations like steam power and hydraulic systems, making modern elevators possible. Safety revolution. The invention of safety mechanisms like braking systems and automatic controls revolutionized elevators, making them reliable and safe. Modern use. Today, elevators are essential in high-rise buildings, and advancements in technology have led to faster, safer, and more efficient systems. Understanding how elevators have evolved helps underscore why it's critical to apply traffic analysis when selecting elevators in today's complex buildings. What is traffic analysis? This slide provides a definition of traffic analysis and its role in elevator selection. Traffic analysis defined. Traffic analysis is the study of the expected flow of people and goods in a building, which helps determine the number and capacity of elevators required. Optimizing movement. The analysis assesses how people move through a building and ensures smooth transportation by minimizing waiting times. Key factors. It takes into account building occupancy, peak times, for example, morning rush hour, and how people are distributed across different floors to optimize elevator placement and operation. By carefully considering these factors, we can ensure that the right number and size of elevators are installed. Factors considered in traffic analysis. Several key factors influence how many elevators are required in a building. Building occupancy. The total number of occupants at different times of the day helps determine elevator demand. Larger buildings with high occupancy will need more elevators to manage traffic effectively. Peak usage. Times. Busiest times, such as morning rush hours, lunchtime, and end-of-day exits, need to be considered to avoid long wait times. Floor distribution. The number of floors and their specific functions, whether they're residential, office, or retail, can affect how people use the elevators. For example, higher floors in office buildings may experience different traffic patterns than lower retail floors. Special considerations. These include accessibility needs for individuals with disabilities, the architectural layout, and the possibility of future growth, which may require more elevators down the road. Benefits of traffic analysis. This slide highlights the benefits of conducting a thorough traffic analysis before selecting elevators. Reduced waiting times. A precise analysis ensures that enough elevators are available during peak times, reducing waiting times. Improved efficiency, properly selected elevators optimize the movement of people, preventing bottlenecks and improving the building's overall operation. Enhanced user experience. By providing efficient, reliable service, elevators improve the overall experience for tenants, employees, and visitors. Cost savings. Traffic analysis helps prevent the costly mistake of installing too many or too few elevators, saving both initial costs and long-term operating expenses. Challenges in traffic analysis. While traffic analysis is essential, it comes with its own set of challenges. Complex traffic patterns. In large, multi-purpose buildings, predicting how people will use elevators can be difficult due to diverse user groups and overlapping functions. Changing usage patterns. Over time, how a building is used may change, making it necessary to re-evaluate the elevator system periodically to maintain efficiency. Limited space. In some cases, the building design may limit the number or size of elevators, complicating the analysis. Balancing cost and performance. The challenge is to balance cost-effective solutions with the performance needed to meet traffic demands without over-investing. Importance of accurate traffic analysis. This slide emphasizes the consequences of poor or inadequate traffic analysis. Inadequate analysis results. If traffic is not properly analyzed, the result may be long wait times, overcrowded elevators, and general dissatisfaction among building occupants. Insufficient capacity. Underestimating elevator needs leads to congestion, delays, and decreased productivity, especially during peak hours. Overestimating demand. On the other hand, overestimating traffic may result in unnecessary costs for installing more elevators than are actually needed. Accurate analysis. Ensuring the traffic analysis is accurate allows for an elevator system that meets the real needs of the building efficiently and effectively, offering both cost and operational benefits. Tools and techniques used in traffic analysis. In this final slide, we discuss how professionals carry out traffic analysis using various tools and methods. Computer simulations. Advanced software allows engineers to simulate elevator usage under various conditions, helping predict traffic flows accurately. Data collection. Gathering real-time data on building usage patterns and occupancy is crucial for making informed decisions. Expert knowledge. Experienced professionals bring valuable insight into the process, from understanding how elevators operate to anticipating future needs. Case studies. By analyzing elevator systems in similar buildings, professionals can make better recommendations based on what has worked or failed elsewhere. In conclusion, traffic analysis is a critical process in determining the optimal number and size of elevators for a building. By carefully studying factors such as occupancy, peak usage times, and floor distribution, traffic analysis helps ensure efficient vertical transportation, reduces waiting times, and enhances the user experience. Accurate traffic analysis not only improves the functionality of a building, but also helps balance cost and performance, making it a vital tool in modern elevator design and planning.